In this video, we're going to talk about how to write the equation of a parabola given the vertex and a point. So remember, we talked about how to identify the key characteristics of a parabola based on its equation in vertex form. The first thing we can identify is whether it's a vertical or a horizontal parabola. If the term being squared is x, that means it's a vertical parabola. If the term being squared is a y term, then that means it's going to be a horizontal parabola. We can also determine the direction of opening and the vertex, and for vertical parabolas, we can determine whether the vertex is a maximum or a minimum. We can also use the equation to figure out the axis of symmetry. Another thing that I want to remind you of that we'll be using in today's problems is how to square a binomial. So for example, if we have x minus 5 squared, you can expand that out using either FOIL or the perfect squares pattern. So if you're using FOIL, you're going to identify the terms as first, outside, inside, and last, and then multiply. And then remember, finally, you want to add up all the terms, remembering to combine like terms. I actually prefer to do these using the perfect squares pattern because I think it's kind of like a shortcut. Because if you have a minus b squared, that turns into a squared minus 2ab plus b squared. So if I'm doing x minus 5 squared, that's just going to be x squared minus 2 times the product, which is x times 5, and then plus b squared. So that becomes x squared minus 10x plus 25. So I'm going to be using perfect squares to expand these out, but if you prefer to use FOIL, feel free to do so. So what we're going to be doing today is writing an equation of a parabola in vertex form, and then taking that equation and converting it to standard form. So you'll start off by using the key features to identify the values of a, h, and k, and then we'll plug these values into vertex form. Then we'll convert the equation to standard form, which is y equals ax squared plus bx plus c, and we're going to do that by first expanding the square term, and that's where we need to use either FOIL or the perfect squares pattern. Then we'll use the distributive property to simplify, and then finally combine like terms when we can to simplify. So let's start off with this problem. So let's write the equation of the quadratic function that represents a parabola that curves up, has a vertex at 2, 1, and passes through the point 4, 2 in vertex form. Then convert this equation to standard form. So if it curves up, that means that's going to be a vertical parabola, right? So we already know the equation is going to be y equals a times x minus h squared plus k. Okay, so it says we have a vertex at 2, 1. So the vertex at 2, 1 means that's the value of h and k. And then it tells us that we have a point at 4, 2. Well, the point of 4, 2, it just gives me an x and y value. So I can actually take all of these values and plug them into my equation. So I have 2 equals a, which I don't have any information for a, except I know a is going to be positive because it curves up. And then I have x, so I have 4 minus h, which is 2, squared, and then I have plus k, which is plus 1. So I have 2 equals a times 4 minus 2 is 2, so I have 2 squared plus 1. So now I'm going to turn this into 2 equals a times 2 squared is going to be 4a plus 1. And then now I can solve for a by now subtracting 1 from both sides. When I subtract 1 from both sides, I get 1 equals 4a, and I can now solve for a by dividing both sides by 4. So when I divide both sides by 4, I get 1 over 4 equals a. So if I plug this back into that original equation, I have y equals 1 over 4 times x minus h, so minus 2 squared, plus k, which is 1. So that's the equation of this parabola in vertex form. Well, now I want to take this equation, y equals 1/4 times x minus 2 squared plus 1, and I want to convert it to standard form. Remember, standard form is y equals ax squared plus bx plus c. So what I need to do first is I need to expand out this square term. So that's what I was talking about using the difference of squares. So remember, that tells me that a minus b squared equals a squared minus 2ab plus b squared. Okay, so if my x is a and my 2 is b, this is going to be y equals 1/4 times x squared minus 2 times a, which is x, times 2, which is b, and then plus 2 squared. Okay, and then I have plus 1. So let's simplify everything we have on that inside of the parentheses. So we have 1/4 times x squared minus 2 times x times 2. Well, that's just going to become 4x. And then I have plus 4. Okay, and then I still have my plus 1 on the outside. So now I have this 1/4 in front that I'm going to distribute to all three of these terms. So I have y equals 1/4 times x squared minus 1/4 times 4x plus 1/4 times 4 and then plus 1. So I have y equals 1/4 x squared minus 1/4 times 4, that's just going to become minus 1. So I have minus 1x, and then plus 1/4 times 4, that's just 1. And then I still have that plus 1 at the end. Okay, so let's see what we can simplify here. So we have 1/4 x squared minus 1x, I'm just going to write as minus x, and then I have 1 plus 1, that's just going to become 2. So this is now my equation in standard form, right? So notice that this is in y equals ax squared plus bx plus c form. Okay, so now let's go ahead and try writing the equation of the parabola that's represented in this graph, and let's write it in vertex form and then convert to standard form. So let's look at this parabola. It opens sideways, it opens to the right, so we're going to need the form of the equation x equals a times y minus k squared plus h. Once again, we have the vertex. The vertex is at negative 1, 4, so that's going to be the h and k values. We have 1, 2, which is a point, so that's going to give me my x and y values. So let's plug this all in. Plugging this all in gives us the equation 1 equals a times 2 minus 4 squared plus negative 1. So we have 1 equals a times 2 minus 4 is negative 2, so we have negative 2 squared minus 1. Negative 2 squared is 4, so we have 1 equals 4a minus 1. So now let's solve this equation for a. So we start off by adding 1 to both sides, and when we add 1 to both sides, we end up with 2 equals 4a. So now we can go ahead and solve for a by dividing both sides by 4. So we have 2 over 4, which reduces to 1/2, so we have 1/2 equals a. So let's go ahead now and plug this all back into that original equation. So we have x equals 1/2 times y minus 4 squared minus 1. That's the equation of this parabola in vertex form. Now we need to go ahead and convert this to standard form. So we have x equals 1/2, and then I'm going to expand out that square term. So I'm going to once again use the perfect squares trinomial. So that's going to be y squared minus 2 times the product of these terms. So 4 times y is going to be 4y. And then we have plus 4 squared. Okay, and then we have minus 1. So we have x equals 1/2 times y squared minus 8y plus 16. And then we have that minus 1. Now we need to distribute this 1/2 to every single term in this trinomial. So we have x equals 1/2 times y squared minus 1/2 times 8y plus 1/2 times 16 minus 1. So we have x equals 1/2 y squared minus 4y plus 1/2 times 16 is going to be 8, and then we have minus 1. Okay, so that 8 minus 1, I'm going to go ahead and combine. So we have x equals 1/2 y squared minus 4y plus 7. Okay, so that's the equation of the parabola now in standard form. So now you can go ahead and pause the video and try doing this example on your own. So here you can see the parabola opens up, so it's going to be vertical. So we use y equals a times x minus h squared plus k. We have the vertex, which gives us the values of h and k, and we also have a point, so that gives us an x and y value to work with. So we plug this all into vertex form, and that gives us 1 equals a times 0 minus negative 3, which becomes plus squared minus 2. So we have 1 equals 9a minus 2, and when we solve for a, we get a equals 1/3. So in vertex form, the equation will be y equals 1/3 x plus 3 squared minus 2. And now we're going to expand this out. So this is going to be a perfect square binomial where we have a plus b. And remember, that's going to be a squared plus 2ab plus b squared. Okay, so a squared is x squared, and then 2 times the product, well, 3 times x is 3x, and then 2 times that is 6x, and then we do b squared, so that's 9. We multiply every single term in this trinomial by 1/3. So we have 1/3 x squared plus 2x plus 3, and then we still have that minus 2 at the end. In the final step, I just combine that 3 minus 2, and that's how I get 1. So the equation in standard form is going to be 1/3 x squared plus 2x plus 1. So remember, given the coordinates of the vertex and a point on the parabola, you can write the equation of the quadratic function it represents in vertex form. Then you can use algebra to convert this equation to standard form.